while we're doing this kind of course series, all of our homework will sort of contribute to maybe like a token manager boost or something like that. That sound neat?
Yeah, that'd be cool.
Do we think there's like overall any use for that, or okay?
Like a new token. So we'll make a new token, and then as I'm just trying to think of what managing would mean in a DAO context.
What we would have to do is somehow get the address of the token that we create back into the front end, or I guess maybe not into the front end, into the subgraph. And we would want the settings of this boost to be like a sort of like a token manager UI, and there'd be a bunch of forms for every token that we've summoned with this boost, and then there's a bunch of different actions you can take.
That could be a bolt-on.
Yep. Yeah, it could be that too. Yeah.
So this boost would just launch the token into the minion and make the minion the owner.
Yep.
And the minion could wallet connect into a bolt-on.
I'm good for either. This, unless there's something significant I'm missing, though, this might be one of the more easier tasks for Boost to take on, besides like building a little one-page UI and a bunch of forms for. It might be like something that it's good at. We can try. I just wanted to have some homework that may or may not get used for something. I agree on the bolt-on, though. Maybe some specialized UI would be kind of sweet. Could be another lesson.
A bolt-on lesson.
Yeah, definitely. Okay, looks like we got a decent number here. So I'm gonna start rocking. So I guess probably an overview of boosts and these little code Legos. So I'll start with boosts are a sort of like they're a bit of extra functionality that you use that your DAO can sort of connect to. So usually that's mediated through a smart contract called a minion, which is an interface between your DAO's proposal process and some other smart contract out there in the Ethereum space. And boosts are a way of customizing our front end so that we have different ways to interact with these minions and outside contracts. Also, boosts can interact with other APIs that are non-crypto related, but for the sake of today's little tutorial, we're going to do a boost that is strictly an on-chain boost. And the reason we're doing that is because we do have sort of these rails for building these out relatively quickly. Not gonna say it's super fast or anything, but it definitely helps things along in terms of like building out a form and sending information to your minion so that it can interact with other things and kind of streamline the process. Today, yes, of course.
Are you recording?
Oh, Jesus, yeah. Are we recording?
Yeah, I'm recording.
Okay, sweet. Yeah, good question. So today we are putting out, Deacon was kind enough to make us a token summoner contract. So what we're going to do is we're going to get our DAO to summon an ERC20. Pretty simple example, but I think could be some use and some good follow through homework for everyone involved here if they're interested. So I guess what I'll do is I will start with DAOhaus interface here, and let's go. What I'm going to do is I'm just going to mock up this transaction on a safe minion proposal. So we'll just go to the transaction builder. If anyone is unfamiliar with this transaction builder here, what it does is it's a way for building a custom proposal, a one-off proposal that gets our minion to interact with some sort of external smart contract. So we're going to make a title, test, token, blah, blah, and choose our minion here. And then I need to have the contract address. So I have the DAOhaus token factory right here that Deacon made. So I'm just going to grab that address, and then you just drop it in here. And if all goes well, what this does is it calls Etherscan and fetches for an ABI. It returned us an ABI, so we call the summon token method. We're going to choose our supply, and I don't know, let's do 1 million. 1 million. And this is token 3, and symbol is token. Does it, Deacon, can I put numbers in here? In a symbol?
Another thing on the supply here is that it's 15 decimal. So if you're doing 1 million, you'll need to do 18 zeros after that.
Oh, really? Okay, so it's denominated in like way. Okay, so that's way to ETH. Should have this bookmarked. So if we're doing 1 million, is that 100,000? My eyes are horrible. So what this basically, we are, I guess, the factory takes in the very base units that we're looking for, and this token is hard coded to 18 decimal places. So we need to find the amount of way. I guess it's not really way because it's not ETH, but we need to input the amount of base units that this token needs. That makes sense. Hopefully it does. So that's our supply right there, token 3, and receiver. Now we want the minion to be the receiver here. The receiver, correct me if I'm wrong, Deacon, is the person that owns the contract, quote unquote, and has control over what they mint or ownership, all that stuff. So if we want the DAO to have control over this, we're going to use the minion's address, and we'll put that right in here.
Actually, so this is a super basic ERC20 contract that has minting and burning abilities. Mm-hmm. This supply is really the initial supply, just like what you're minting right off the bat. And so receiver is going to receive both initial minted tokens and ownership of the contract to be able to mint more or burn. So I actually don't want that minion address. I know this because I messed up the other day. We want the safe address because the minion is controlling the safe.
Right. Okay. That makes sense. We've had this sort of thing before, eh? Where you kind of have to target the safe. So that I'm going to the right place. I'm going to go get the safe address that's connected to this minion. That's correct?
That's right.
Cool. So just have to do that again. So yeah, good distinction there. For clarification, our safe minions, what they are is a minion contract that sort of wraps a Gnosis safe. So in this case, we want the address of the Gnosis safe instead of the minion, so that the Gnosis safe that we control with the DAO is the one that has control over the token. Call this big test. Oh boy. Crap. Okay, I'm gonna get an old notepad going here.
Description for now.
Yeah, I'm going to just say minion. When we're doing this, it's always good to have a little notepad going, especially when you start building your boost. I'll show you kind of what I'm doing here. I have a little notepad. It's token factory, minion address, and then the amount, which I'll have to replace now with this. So because you're probably going to find yourself doing this over and over again, and you want to make sure that you have your clipboard free and you're able to do what you need, because there's a bit of a challenge there with copy and pasting values. Deacon likes to use the description box. That's pretty creative. I can tell you've done that a lot. So we're calling summon token. We'll bring in our supply. And token factory. Oh, we don't need that address anymore. We need our safe address here. And this is big test token.
BT?
BTT? Okay, I like that. Nice. And if all goes well, we should be able to get this rocking. And looks like things are good. So I guess while we're waiting for this to run, let's do a little question period if anyone here is a little bit lost or has any questions about what we just did right here before we get into the bigger stuff.
So this contract address is referencing the token contract that Deacon created. And so that follows a standard, yeah, like ERC20. So we have...
Yeah, so this contract is actually what we call a factory. So a factory contract is a contract that makes other contracts. So this is a factory to make standard ERC20 contracts. And then it transfers the ownership and mints a little bit along with that. So what this factory is going to do is going to create a new ERC20 contract and move those things around. And it's just I just used the Open Zeppelin standard, which is the standard for ERC20, but Open Zeppelin just has some audited code. And so most of that's all good, but before we move this to production, we probably want to get just a quick review on it. Because
for sure.
So when you put the contract, from DAOhaus's point of view, you put the contract address in there and it kind of detected the available functions and populated that dropdown?
So what this does is it calls the Etherscan API, and it says like, hey, what's the ABI for this address? When we enter this address, we make a call Etherscan. Etherscan says, but only if it's a verified contract. If it is, what it's going to do is it's going to return the ABI to us, and then on our end, we chop up the ABI, and we turn it into a select, and then we choose the functionality that we're going to use. And then that functionality determines what is rendered here and what we're sending to the smart contract.
Okay, so we're going to send those arguments, and then we can assume that summon token is a function that takes those arguments and makes a token and all of the ramifications of that.
Mm-hmm.
And then
I can even... Sorry, I didn't mean to cut you off there, but when we're done, I can show you this here.
Okay. And the receiver that we specified, you made that Venosa safe, and so that safe is kind of like the owner of the token, or it has I can't remember the terms, but basically like admin privileges in there to do the initial distros and things like that.
Yeah, that would be the safe. The safe that we're using has the sort of the admin privileges, which gives that to the DAO essentially, because the minion is controlled by DAO proposals. So if you want a DAO to do some sort of action with the token, then you do a proposal to do this, and if you want it to do something else, you do that.
And it needed to be a minion because the minion is what has the ability to call external functions. Right now,
you got it.
We're not using the minion to call the external function, but we're making it the rep for the token so that later we can.
That's a fine distinction that I think Deacon might be better off answering there. I don't know if it's, I guess it is probably the safe that's doing the calls. Am I correct? Or
it's all these Legos, right? So the minion basically is working as an interface between the DAO and the safe. And because the safe is going to be owner of these tokens, that's who's actually making the calls. The DAO, the minion basically forwards some instructions to the safe to execute. It's like a little shim in between, these two.
But the safe does the... Is it technically accurate? It kind of gets into, like, how does Gnosis safe... Like, is it accurate to say the safe is doing it, or are we wrapping the safe or something like that? But that functionality comes from Gnosis safe functionality to make external calls.
The minion will make an external call based off of the state of the DAO. So if the DAO votes yes on a proposal, it can execute, and we'll see the whole process then. What it's actually executing is in the safe to execute something.
Yeah, I guess that, like, the little distinction and homing in on is like the minion and the safe. Do they have the same address?
No, they have different addresses. That's why we had to go into the dashboard there, our minion dashboard, and find the safe address.
Okay, and so the safe address is the one that we put into the token. Yeah,
put the token into, yeah, for sure.
Okay.
The safe is a contract wallet, and the minion is like a little agent for the DAO. So the agent can only do things that the DAO tells it to do, and one of the things it can do is control this contract wallet.
Okay. So there's 3 addresses or 3 contracts at play once you use a minion and a safe.
The DAO, the minion, the
yeah.
safe.
Yeah. Okay.
And now there's
if I got this right, if I got this right, so the minion is kind of the in transit, the temporary holder for the instruction to do the call. So the results of the call will be stored at the safe, but the minion waits for the votes, and after the votes are voted yes, for instance, then the minion carries the execution to transfer the funds to the safe, right? So the safe is the storage, and the minion is the agent, right?
Yeah,
that sounds pretty accurate.
So did you already vote and execute on this?
Yeah. So this is the details right here. Now, when I did this using the factory just myself on Etherscan, I was able to see the token that I summoned, but I guess because this is encoded, we're not going to be able to see that, eh?
Which transaction are you looking at here?
This is this one that we made.
Okay, so this one will actually be a submit proposal.
Oh, right. Yeah, of course. Yeah, because it has to go through the whole. Yes, right. It's been a while. So yeah, this is, I guess we could probably continue question period here. We got a couple minutes of proposal process to go through.
The thing you can look at here is in the details of this proposal.
Yep.
And that'll show that
this is all the
actions that is being stored waiting for a successful vote. So this is the action that can be executed if the vote passes.
I gotta be pretty fast here.
Question there. So suppose this proposal goes through, the tokens are created on the safe, and they can be managed normally through the DAO. For instance, creating a token swap proposal or exchange shares for tokens. But if I need to mint more, I would have to do the same thing again. So call another transaction for the minion to mint more. Is that how it works?
Yeah, you would have to, like, if there was no boost, then what you would have to do is use that custom transaction builder for pretty much everything, which, is fine for some, like, if you're exploring or if you want to try things out. But generally, the idea is that if there's a simple transaction that you're calling that you can automate, you can use the systems here that I'll show to you guys to build a boost to sort of automate that process and make it a little easier.
Thanks.
No worries. So, we got a minute here left still. Any other questions?
What is our plan for today? Like, what are we going to accomplish?
Okay, that's a great question. So what we're going to do is, so when we put together this minion proposal, wrong one. This multi-TX, we had to go through here, and this example, it's not super dramatic, but so when we wanted to do this, we had to, create the proposal title, all this stuff, choose our minion, and then we have to choose a contract address. Like, we can automate some of this stuff out of here, right? We don't have to do this every single time. Now, in the case of the function that we're calling, it's not super dramatic just because, It's not super dramatic because this is a relatively straightforward, who's doing that? This is a relatively straightforward contract call that we're making, but some of them can get really, really beefy. Like if we wanted to look at, say, some of the methods for like the Moloch DAO, submit vote. Submit vote is pretty relatively straightforward. What's some of these? Not vote, sorry, proposal. Like, there's a lot of arguments here, and we could maybe, I don't know about this particular use case, but the idea is that you can narrow it down and eliminate some of these fields so you don't have to fill this crap out every time, right? And that's what we want to do with this today with this boost is kind of narrow down the token thing, the token summon, so that we don't have to do this every time. And it's just it's more straightforward. There's less guesswork and less ways to screw it up. Better UX overall. Does that make sense?
Yeah, so it's going to be the actual summon of a new token, just with like fewer form fields or some sensible defaults or something.
Yeah, exactly. Let's make a little work plan. Oops. Okay. I would have did the minion address instead. So let's make a little work plan here. So we'll always have to select our minion, so we can't really automate that because your DAO could have more than one minion, and you always want to be able to choose. But we can automate the contract address, right? We know which factory is going to be on per chain, so we know we can take that out. Supply. We're going to have to put supply in, but maybe there's a tool that we can use so that we don't have to go to ETH unit converter and enter in Way. Also, people aren't generally going to know, like myself, I started using this and I didn't know that I had to convert to Way. So it makes it's more helpful to people if we have something that kind of wraps an input like this and is just in its in its main units. In my opinion, that would be better UX. And then these will leave. We want people to leave the name and symbol of the token they want. But this one right here, we can automate so that it takes in not the minion address, but the minion safe address, so that we don't have to go find some other value in the minion dashboard. So it'll kind of like take away some of the guesswork here and make it a little easier. And then someone can publish that boost, make a pull request, and then any DAO will be able to use that.
Yeah, I think a thought that occurred was we could call it like the min to million boost, and have it be like mints 1 million of a new token or something.
So you want to hard code in 1 million?
Or maybe like how many millions would you like to make or something like that. And then, you don't have to, but it's like mint 1 million would be, I like how it sounds, and it could just be like, yeah, that's the thing you can do, mint 1 million tokens.
Oh, let's hard code that.
Okay.
Then let's get, we got a few minutes left on execution, but should we look at the code now?
Oh yeah, for sure. Actually, I'm just gonna get this to go here. It should be good to rock. But yeah, so we're hard coding 1 million. That's actually easier.
And
I will show you the code here right now, actually. So the way we do this, it's sort of a strange system, but we try to turn everything into static data so that we can use the same functions and the same sort of API for building forms and building crypto transactions, and we don't have to keep building out new functionality. It was just like a radical way of sort of refactoring a crazy amount of code that we had. We had something like 40 forms and 50 transactions, and we needed to kind of pare down. And then while we were paring down, we sort of discovered that you could use this to build out new boosts relatively quickly as well. So this is how we express a form, for example. It looks like this. It's all just constants, just static data that doesn't change and is relatively predictable. Same with a crypto wrong window here, TX, Moloch TX, yeah, there we go. So these are a way of describing an Ethereum transaction in static data. It's sort of like the opposite of the ABI. The ABI says what it needs, and this says what it's getting. And we have some little lifecycle methods, actions that we can propose when the proposal passes, what poll we're going to use so that we can update the UI based on the subgraph or whatever we're looking at, and some display error messages, all that stuff. I'll go into detail on each one, but just thought it would be useful to give like an overview. First, we should get this and see if it actually executes. That would be all right. Looks like we're ready to rock. Yeah, so here there's 3 entities that I think Boost developers should mainly concern themselves with. There's the contract Legos. It's a relatively simple one. It basically ties the ABI to some sort of object and it'll tell us where that contract address lives. So it'll tell us either to fetch for it, or it lives on our application, and where in that application it lives. Because sometimes we want a minion that exists in a form, or sometimes we want one that exists in our collection of chains. Chain data, like data specific to each network. So we have this massive blob here. Often we find ourselves looking for endpoints here. Sorry, this is getting in the weeds, and I'll be able to explain this kind of better later on. But essentially, we're going to be trying to traverse data trees like this in our application, or we're going to try to be traversing React context in our application, and we're going to be giving the application instructions or queries to do so with a notation, like a dot notation that looks something like this. The 3 entities that we should mainly be concerned about as Boost developers is these contract entities, the form entities like these, and the transaction entities like these. You notice in the transactions, when we're gathering our arguments, what we're doing is we're just basically looking through either the form or the application for certain values, and then we're going to send that to the smart contract. It's kind of like a query basically, but we're querying the application and not some sort of API, or sorry, not some sort of server. And let's see. So we got our transaction passed here. Let me just pop this open. Activity. And here is our big test token that we created. So you can see has a total supply of 1 million here and 18 decimals. That's hard coded in. Has one holder. And if we look at holders, I guess that would be because it's all in the minions. And we have the both the methods and the view functions here that other ERC20s have. So later on, we could also write boosts that interact with the token that we create. Right now, though, let's make a form. So what I'm going to do, I like using posters stuff because it's probably the most stripped down. I'm just going to copy a big form Lego here, like just verbatim, and then bring it into... Probably good to explain where all this stuff lives first, eh? So inside we have our source/data, and then in here you're going to see a lot of our Legos. The special folder for form Legos and TX Legos, you'll see they live here. You can see we have a lot of them. So yeah, let's start with this. Reason I start with forms first is because if you build your form, then you get a really fast UI for testing out your transaction afterwards. So this is going to be, what should we call this boost? Is it really, we're doing mint a million?
Mint a million.
Mint a million dot JS. Mint a million forms. I want to put the forms in there so that when I'm searching through the repo.
Just a question. This mint a million will actually create a new token, then mint 1 million. If I call it again, it would create a new token, right? Not just mint another million on the same token, right?
Yeah, that's correct.
How did name collisions with tokens? Does it matter?
I don't think so.
Doesn't matter. It screws us up sometimes on our indexers when we're like trying to get the price and stuff when people have the same name on a token. But all tokens are, have a unique address. The name and the symbol can be whatever you want.
This leads to all sorts of scams. People try to create tokens with the famous names just to get you to buy it.
Yep, that's true. And so I always check the address.
I think this boost is going to be really popular. People can be like, I want to mint a million.
We're going to release a boost called Mint a Million. We're not going to give them the option to mint how many they want.
Well, you can always do that behind the scenes if you want. But people like it simple, It's exciting. Get the people going.
Okay, so what I'm doing here is I have the million forms, and this is just like an object that holds all the different forms that we'd use for this boost. In this case, it's really just one, but to make it fit in with the API that we have already, it is good to kind of follow the same pattern. So let's just save for now. Always make sure that you have the double-sided identifiers with any of these boosts, I think, except for contract, if I'm not mistaken. This just like in our system, there's a lot of like data work that's happening, and the models get switched between objects and arrays a lot, so it's good to have that double-sided. It's one of the required fields for sure. So let's go to forms here for a second, and we're going to spread out our million forms, and inside a form here. And then let's go back to the poster boost. Oh, come on. And let's just start going through. So I'm going to do dev is true, and someone remind me to explain what that means if I forget by the end of this. I'm just going to go through everything here line by line. So title is going to be the title of your form. I think it's what appears is like the main heading of the form. When that form pops up, there's like a heading, and yeah, this just tells you. So mint a million right here. We have a description. This is a sort of subheading. Mint a million of a new token with an exclamation point. Gotta have the exclamation point. So we got description here. Type. So this, having a custom proposal type allows you to render a different type of proposal card with some sort of custom UI. So yeah, we're going to need to do that as well. Okay, so in here you see proposal types, poster, ratify. So what we're going to do is bring in that same proposal types entity. And then we're going to go into it. And you see a lot of different proposal types that we have. And we're going to do proposal types, mint million. And I'm just going to say mint a million. And then we should see it here. Again, so I guess probably maybe a visual way to explain this. Each one of these proposal cards here kind of needs a way to tell it what UI it's going to render off. And it's sort of tough for that data to get transferred. We started with the app trying to infer what shape the proposal will come in, but trying to guess every single type of proposal didn't really work out that well for us as we, started having like 40 or so different proposal types. And we needed more and more sophisticated UIs to present based on that proposal type. So that's why we have the type here. Why doesn't it like the title? Okay. Whatever. Minion type. So we know what minion type that is. What minion type is this? Someone from the back.
Is it the safe, I guess?
Yeah.
Safe.
Just making sure people are awake.
There's a couple different minion types, but I think mostly going forward it should be the safe.
Yeah, exactly. So minion types is an object here. It basically, again, just another little enumerator that has all of our different minion types. We have no pattern whatsoever for how we type out our minion types, so we needed this object to kind of keep that organized. Next thing here, custom width. Actually, we're not going to do custom width. We're just going to take on we don't need that. We can use a normal width form.
If you don't know what to choose, that's the safest option, right?
The safest option, right. Yes, exactly. I would say just in general, use the safe minion, always. It's the one that we probably have been supporting the most, we've been building on the most, and the one that's probably the most up to date. So it also has by far the most functionality. Minion type, and we're not doing custom width, but if you did want to control the width of your proposal, you could use this, and it basically just, in this case, for poster, we needed to put a markdown editor in there. So you don't want a markdown editor that's like 200 pixels wide or 400 pixels wide or whatever. So there's an option to have a custom width, and so I went with 1,000 pixels here. And TX, let's leave. This is where the transaction that we're going to build is going to live. Let's leave that as null for the moment, just as a placeholder. If we try to fire the transaction, obviously it'll break, but we haven't built it yet, so we don't know what we're going to be putting in there. Required is the fields that are required. So if we tell the form what is required, it will stop us from submitting it, and if they're not filled out, and it'll leave you a little bit of UI and validation to kind of nudge the user along. And then we have our fields. This is kind of the tricky part with forms. You got to do an array, and then you would want to do an array for however many columns you want the form to go in. So for this one, we just need one column. So we're going to do an array and then an array inside of it. And then we're going to start building fields. But first, let's do a little question period. I'll slow down here for a second. We're good? Everyone knows everything about what I'm talking about here?
Kind of surprisingly, I feel pretty up to speed. I've seen this once before, not at this detail, but so far, so good for me.
Cool. All right, sounds good. So what are we going to do here? I think we should go into fields. Fields is a lovely file that is very concise, as you can see. But you can see that like all these fields are kind of a very similar shape. It basically, we're going to tell what input we're going to render, what label. So the label is, if you're looking at a form field, right, if we're just going to open, the label is this. The thing it renders is the combination of this. So if we want a text box, then we're going to use, type equals text box. If we want an input, we're going to use type equals input. And then we can control, what else can we control? Like placeholder, all the kind of the HTML input stuff that we generally use. So placeholder, HTML4. Info is, I don't know if we have it here, but info, if you have a string as the info property, it will render a tooltip for you that provides the user some info about this particular field. Also, as I said, the required validation will check that we're submitting something that is required automatically for us and leave us a little validation message at the bottom there. It should also do type checking for us. So, so if this is expecting, it's expecting an integer, but if we put in something else, it'll automatically detect, it'll look at this and automatically provide us a bit of feedback here. How it does that is this expect type field here. So you see different expect types: address, number, any is any string. So I think we have also like integer. I think there's got to be a couple other here. Maybe not. There's like an array, I think. And that's pretty much that. That's what a field looks like. So I think instead of kind of polluting this, let's make it a little easier for us and kind of. This is what I do when I usually build a boost anyways, is I sort of start with the basics and then I'll refactor over to field and kind of file it in as need be or as I need after. So, right, what do we want to ask from the user here? So we know that if we're looking at this, Safe Minion Classics, Transaction Builder, and we've chosen our minion. What fields do we need from the user? So we know supply. Yeah, we know supply, and we know the receiver here. So what's going to be left over is name and symbol. So this input is literally going to have 2 fields or 3 fields on it. We're going to select a minion. We're going to do name and symbol, and it's going to do the work for us, the rest of the work for us. Does that sound good? Everyone's on board? Sweet.
Could it show the supply as 1 million by default and allow you to change it?
Yes. Personally, I think we should be entering in the supply, but yeah, we could do. I don't think we have a hard-coded default value, but I could try. Let's see. Let's try with the hard-coded million first, or either that or like an open supply thing. I'm okay with either. I think let's continue with the hard-coded thing, and then we can go from there and try to see if we can get a default value with the input. I haven't really played around with that in a while, but that's a good point. You would want to be able to change that, of course.
You would think so. It makes so much logical sense. I feel way more excited about just minting 1 million for some reason.
I actually like that. It removes some of the context overload, but that's what we should put it.
Okay, so that's what we're doing. Basically, we need a field for the minion select, the name, the symbol, and that's pretty much it. So we need 3 fields. So let's do the name and symbol one first because they're the easiest. So what do we say? Token name, and then let's call this token name. So this, as far as fields go, this is where you want to pay attention. This name property here is everything. Like when we try to find those values that are in the form and send it to the transaction builder, this is what it's going to be looking at. And so when we even our validation, that's the same thing. So if we want to validate this as required, which we certainly do, we would want to put that in there. Same with this, HTML4, I regret putting this in, should just do that by default. But what are you going to do? And then just put token name as a placeholder here. And we are expecting type any string, whatever they want. It's their token. And then we have the token symbol. And that is an any as well, because as we learned today, you can do numbers as your symbol. So there we go. And then I am actually concerned that minion select, there might be some challenges with that. But let's just throw it in. So we have a pre-built field here that we use in so many of our boosts already, and that's the field minion select. The good thing about putting them in here is that if you do have something that would be useful for other people. If we put them in here, then other people, instead of typing out their fields over and over again and building new stuff, you can just reuse things, which is really sweet. Now, I'm going to have to get sort of in depth here because there is a fine distinction with the minion select. So the minion select, usually what it does is it basically just renders off this thing, this input right here. So if you put minion select in your form, it's going to render this off. And it needs to know which type of minion that we're looking for. So we got to put that in. But also, it returns a value that is your minion address. But as we learned earlier, we don't want our minion address. We want the safe address. So we got to keep that on top of our mind, or maybe in the back of our mind, actually, for later when we start trying to debug our transaction. How do we get the safe address from this input? And I think that problem's already been solved, but just in case it isn't, then we got to do a little custom coding here.
It'd actually be nice to have that address there too, maybe even instead of the minion address, but that would be changing that field in the future.
Yeah. Yeah, I agree there. That would be helpful, because it seems like every single boost that we do, generally we're looking for the safe address. So yeah, something to think about, or even just some sort of both might be good too. Okay. But right now, we're just going to leave this as is and see how it worked out for us. See if we break everything or not. So we have it on dev as true, right? Okay, so if we want to see how our form looks and test it out in the DAOhaus UI, what we do is we put this dev equals true, and then we're going to go to proposals here, manage. Oh, and we still have all my old. I wonder when those are going to get taken out. Okay. Mint a million right here. And you know what? This shouldn't be in all the poster things. Just going to do a little cleanup here while in the middle of the tutorial. Bear with me. Actually, I'm just going to take them out. These are left over from like a month ago when I was building this boost. Okay. So if we come back here, refresh, we should see one form. And that is our mint a million. And here we have it. So it builds out automatically for you. So we don't have to do all the React work, setting up the controlled inputs, setting up the validation. It should just do that for us automatically. If we're going to do the same thing over and over again, let's build something to help us with that. Now this is what I want to know. What values are we getting from this input here? Now, we could go into the React code and dig really deep, but before we do that, there's one other thing, and I forget the name of it, but it's another useful tool. I think it's log values. If we go to log values is true, we should be able to open up. Sometimes with this, because it is static JavaScript data, you have to refresh stuff, which is a horrible pain in the ass, something we'd like to fix on the next one. But yeah, so what it does is it logs out the React hook form values so that we can see what changes when we do something here. So if I select our min, it looks like we have the selected safe address right here. So we are able to. We don't actually need to go into the React code or anything. We can just look at this and say, oh, form already does that for us. And so that's something we want to validate for. This is the name. Remember this holy name here. This is the name that we're looking for, and that's what we're going to be getting when we want to do our transaction as well. So we want to validate this, and we that to be in our transaction Lego as well. So just keep that in the back of your mind. And I think that's pretty much our form right there.
What was that logging flag that you set?
Yeah, log values is true.
Values.
Yeah, so that shows all the state that is inside of your form. It's pretty handy if you're trying to see like what names things are being recorded as, and see if you're trying to debug and maybe your inputs isn't behaving as you're expecting it to, and it's not sending the right data to the transaction builder. This is something you'd want to see in order to debug. And what it will do is it will update on every single keystroke.
So is that the object of collected data from the form?
What's that, sorry?
Is that JavaScript object like the collected data on the form? Yeah.
It's the values object. So what we're using under the hood, if anyone here is familiar with React Hook Form. React Hook Form is this pretty sweet little library. It helps you just sort of automate a lot of the process in React with dealing with forms. React and forms is it's sort of arduous. Like you just have to type out all the same crap over and over again. All these controlled inputs. It also helps with performance too. It uses refs instead of re-rendering and controlled inputs all the time. It's relatively reliable and a pretty convenient API in general. So highly recommend it. But we wrap React Hook Form, and React Hook Form gives you a values object, and that values object is what we're logging out. So it's the values that React Hook Form has, and that's basically any values that are in the form. We can also like add custom values. Like if we want, we can build any sort of custom input, like wrap and then render them out. So if we want a custom input that adds a values there without getting it from the user, say like that's what this is doing, right? Generally, this would just be the minion address. But as you can see, I think Santiago's been hard at work adding a bunch of extra data that should be coming with this if you choose a minion or a safe minion. Does that make sense?
So that selected safe address, that's like some background functionality that kind of based on the minion select. Is it because that's a form field with some functionality built in?
Yeah, exactly. And what this select does is it injects a bunch of data into that values object automatically for you. So I guess we could go into that if we want. If we want to see like the code and how that works, so we can go into minion select, the field, and we can see this one's a pretty busy one, but you can see that. It's Owen that did it all. That Owen, what he did was registered a bunch of different names to go into that values object, and then we have ways of updating that based on the value that the user chooses. Does that answer your question?
Yeah, it does.
Sweet. Also, something to note. I put selected safe address here, and that's sort of like a side effect thing. It's not going to work for the validation. So what we need to do is it's actually more simple than that. We just go in here, find the name, come back. The name of the input is always king when it comes to validation. So it's something to keep in mind, one little distinction. So now our validation should be complete here. We go up. There we go. So we have validation, required validation on each of these. It'll let us know if we try to submit without them. Then we choose our minion. It updates our values, and then we're gonna start working on the transaction. And then we should be able to submit and fire off what we need. Okay. How are we all feeling so far? Feel like we're grasping the form?
Yeah, it makes sense. A question, will we get all the way through this? Like, so far, to do this, all you'd really have to understand is how a JavaScript object is structured.
Yeah.
Are we shielded from kind of like needing React? Like, would we expect a Boost dev to understand React at any point to do this?
I think you can get started with this, but in my experience, most Boosts need some element of custom functionality. There's a few that don't. They're pretty lucky, but most Boosts needs to get into the React at least a little bit at some point. It would be sweet if you don't even need to know React and you could just plop one of these JSON blobs together. Ultimately, like, the goal for this one day would be sweet if we never have to write any of this at all. Like, you don't even know how to, you just use a graphical interface to put this together, and then the graphical interface poops out this code that just gets the app reads for you. That's like, the long-term stretch goal for Boost, or at least it was at one point in time. I don't know. Hoping it might still be, but like that's what we'd like to be. Is that like this sort of data is not super human friendly. It's probably more human friendly than dynamic code, but still. So yeah, to answer your question, if it's a complicated Boost, odds are they're going to have to go into React, but we can mitigate a lot of the heavy complexity of our application because all they have to do is build out an input or two. Most of the custom stuff is done with inputs.
Do you think that we will? This one's pretty simple. Are we going to be shielded from React this time?
I think so, actually. I think we just did it with the minion select, and so in this case, I think we are.
Cool. Yeah, so maybe like a level 2 dive for like that kind of complexity. But it'd be cool if the first pass could be simple like that,
Yeah, of course. I think what we can do next time is we can, instead of doing a million, we can do choose the amount that you want to summon, or the amount that you want. And then we'll just make an input that instead of having to use all of the to go to base units, you could put in the whole units, and then we make a custom field that will automatically calculate the base units for you. And that would be a nice, simple dive into the React.
Cool.
Yeah. Cool. So I think before we start any sort of transaction, it's good to build your contract first. So what are we going to do here? We're going to call this. So these are the contract entities. I think I explained this already. It helps us find ABIs within our application, and summon token, I guess, is a good enough name for now. So we're going to do location, local, ABI name. I like to do, again, matching identifiers. I don't know if it's necessary in this case, but and we're going to tell the application where to look for the actual address. Now, this is where we start getting into search notation. So we kind of built our own little search notation for finding things in the application, so that we don't have to do that with dynamic React code. We can just express this notation, and then it'll find it in the application automatically for us, provided that it actually is in that location. So in this case, what we want is, we have these chain objects, which are wild. They're just like untamed blobs of endpoints and contracts, and they're all sorted by the various networks that we support. So what we want to do is add our contract address, the one that we're going to be targeting. We want to put that in the relevant networks that are available for our boost. So right now, this contract only exists on Rinkeby. So we're going to, basically, that's the only one we have to worry about. So we're going to go maybe here. Looks like a great spot. We're going to do ERC20 summon. And then we will go back to our browser, find the address of the summoner contract, copy that, give it a little paste. And so what this does is it searches the application's context data, it finds the chain config, and then out of the chain config, what it does automatically for you is it selects the network that you're currently on. The network that you're currently on. No, the DAO's network. So the network that the DAO exists on. In that case, this case, it's going to be Rinkeby. So it's going to plop this blob of data there, and then we need to search that blob of data for the key that we need. So it's going to be context data.chainconfig. So that's how we start. And then we added, where is that? Damn it. This is why. There we go. ERC20 summon. Definitely not the prettiest blob of data, but it generally works. Okay, so context data.chainconfig.erc20 summon. So that is telling us where to find it, but we still have one more step here because we never brought in the ABI into the app. So because we're telling it local, that means that it exists on the application here, right? Raw data. So we have to go assets, components, context, contracts. And we're going to do, what are we going to call it? Actually, what are those not the same thing? How come it's not? ERC20 summon. It's probably a better name. And then we're going to name the contract the same thing. ERC20 summon.json. All ABIs are JSON.
There's a typo.
Yeah, ERC10 there. Yeah.
Did I put 10? It's a new pattern. It's an old pattern, I guess. Thank you for letting me know. That would have been embarrassing if I got far with that. And then in Etherscan, you're going to find your ABI. Just go to copy ABI to clipboard. And then we go back to the code, paste. Perfect. So we have our ABI ready to go here. We go to abi.js. And here we see all of our ABIs being imported into our application and then being sort of not enumerated, but being held in this object here. So we're going to do the same thing as Millions has done before us. We're going to import from contracts our ERC20 summon and call it the ERC20 summon. Always go back and check to make sure that, stupid. Same name almost. Okay. That it is the same name. I am just a fiend for copy and paste, as you can see. ERC20 summon. And then that tells the Lego that we have an ABI. It is this ABI. It exists in this folder. And I think our contract, fingers crossed, is ready to go. And if I do that one more time, I'm just going to delete that file. Okay. ERC20 summon. Okay, so now let's get a template transaction that we can look at. So what's a nice Moloch transactions are nice and simple transactions. Actually, that's not the good example because we are using some new shit.
Could we do a quick just like tour of all the pieces you've added so far?
Yeah, of course. So far I have added to contracts.js our contract entity. I have added our form, the one that I put it in the main form object, and then we have our form here. And then I did make some inputs here, some custom inputs, but they're not really that special. So, and I don't think they're going to get reused. If they do, then I will kind of put them back in this field object. So basically all we've done, form, contract so far. Now we're going to start building our transaction. Okay, so what's a good template here? Poster, TX. Now poster has, oh yeah, this will do. I have this new function here. What it does is instead of these massive blobs, what's a good example of a good boost blob here? So this is like a really big transaction, right? There's a lot going on, but there's a lot of boilerplate that we don't necessarily need to write out. So a while back, I made a little function here that'll poop out all this data here for you based on like some just key distinctions. And everything should be customizable. So if you want to overwrite something, overwrite a default, you can do so. You can look at the function here, and everything has some sort of default. All good. Good. What do we name it again? We called it million. Oh, we don't have it yet. So what we're going to do is we're going to go into TX Legos. We're going to make million TX dot, what are we using? We're using two capitals here. Okay, tx.js and export const million 1 million TX. Okay, and summon token. And, oh, don't need to do that. Build multi TX action. And, yep. So we're just going to basically, we have one action here, so not a whole lot. Just going to copy and, actually, no, I'm not going to do that. It's not good for learning. Target contract. What, can I put this question to the crowd here, to the masses? What would be our target contract?
Factory.
Exactly. So, contracts dot, remember we have our ERC20 summon ready to go here. Oh, it's actually going to be ABI, my mistake. And it looks like we have some duplication here. So I'm just going to copy this. That might be something we need to fix. Like it looks like we're looking at twice for the same data. Oh yeah, of course, delete both. Okay, ABI, contracts, ERC20 summon. Function name. What is the function that we're going to call? And so I like to look in here. Oh, come on. ABI. And look at the ABI and get the exact name of the function that we're calling. Oh, that's the event, right, that I was on before? Yeah, this is the function, type function, summon token. And then work our way back to million TX. And then we have to get the args. So let's just look here. ERC20 summon, and you're going to see this array inputs here. So we have to see the array, like the values that we want to gather here, and send to the chain. So supply. We have that number already, right? We're hard coding this, so it's going to make our lives extremely easy. Boom. So that is our first one right here, our first input. We can just send a hard-coded value directly into this. From what I recall, that will work. Name, so... Does anyone have a wild guess at how we get this name value or the symbol value from the form? Okay.
Look in the values object.
You got it.
Yep.
So values, and then so what I'd like to do, I like to go back to my form. And we'll see our names right here. So name, values, dot, token name, lovely little quotes. And I'm just, while I'm here, gonna have the symbol. I'm not 100% sure if that's the exact order, but we can go back to the ABI and check that out. Yep, name, symbol, and then receiver. Okay. The receiver, we had found out in the UI here by logging this out that we want the selected safe address. So I'm just going to highlight this here. Go back to the code. Values dot selected safe address. Forgetting my commas today. I think so. Look, what's that?
You don't have to space that to the minion field or anything, or that's just in the values, I guess.
Yeah, it's already automatically plunked in there for us.
Okay.
So, what are we erroring out on here? What doesn't it like? Oh, we're... Okay, what the hell? Oh, Jesus. Right, this is actions. Right? Sorry, I'm getting too used to TypeScript now. Yeah, it's actions. I guess we're going to want a details to JSON too. Or we could see... Oh, I might poster boost. We can use this for now. Perfect. It already selects the minion safe that we want. Okay. So Just for a little bit of data on the details to JSON. So every single proposal has a details field, which is basically like an arbitrary string of data. We do kind of rely on that arbitrary string of data a lot. So we have these little templates to store things like the proposal title and descriptions, all that other stuff, and into the actual chain data, which actually does remind me that we will need to make a custom details to JSON unless we want to make our own title. What do we vote here? Should we make our own title, or should we just hard code a title in for the proposal?
Where will this appear?
So when you are, see this title here, test token 2 or proposal. So this is a hard-coded title. It just says proposal to ratify content. This one was, we had used a field to discover what the title is.
Oh, I think we should say mint a million.
Mint a million? Just hard-coded? I love it.
Yeah, that's our brand. Everybody's going to want to mint a million.
How many exclamation points should we use?
A million.
A million. Okay. All right, so details JSON, and then we're going to have to go make a custom one, I think. So we can see what we do here. I'm just going to copy that. This is the one I use for poster. I think all we do need is title and proposal type. Oh, you know what? We could also, would there be any value to throwing the token name and symbol in here? I don't think so, right?
Possibly. So you could also do something like hard code mint a million, but then append the token name after or something.
Actually, I don't think I think that's one of the limitations. We could build that in, obviously, but I'm going to meet you in the middle here at the exclamation points and just do 3.
All right. That's like
fair compromise, right?
Third power or something, sure.
And then we'll go back. Oh, sorry. Okay, let's just million TX. Details to JSON. Details, we'll use another one of these blobs here. And then million. Right, so we don't need a description. We don't need a link. We don't need... okay, so let's put this in our form now. If anyone wonders why I keep going to the root level form object, is because they all used to be in one big object. Sort of habit. Okay, so we're going to go to TX, and then TX import dot million. Oh, no, I have to spread it first. Right. So we're going to go to the TX Legos. Right. This is the root level one. Same thing with the form. We're going to spread this in. So million TX, and then it's going to show up here. So if we go million. Why is it going forms? Oh. tx.summon token. There we go. Okay, so, no guarantees here, but let's give it a spin.
You have a way to show how many files you've touched, like get status or something?
Yeah, absolutely. So you can see that right over here. We got the ABI, contracts, details, forms, mint a million. I made a file for mint a million. I cleaned up some of poster, but we don't need to look at that. We have the contract transaction, the million transaction, abi.js to bring our ABI in, and then chain to kind of keep that organized there. And then proposal utils to add our proposal type.
Cool. Yeah, that like a diff of this check-in would be pretty valuable.
Oh yeah, that'd be pretty cool. Yeah, and we could just kind of see all the things you'd kind of need to add. That'd be nice.
Yeah, and for people who are here, we're doing this partly we're going to document this too. So we'll make a video out of this and create a little handbook. So, don't stop taking notes, but there will be more resources to come.
Yeah, and also, I don't think I've ever had this work on the first go before, so let's make this is the million token. Million. And what happens? Oh, whoa. Okay.
First try?
Maybe. We'll see how it executes. So yeah, any questions so far while we wait for this? There's our proposal here. So for Boost developers, we're thinking like there's also other Boost Rails that like help you build out your boosts and your playlists and all the other stuff, how it appears in our like very makeshift little marketplace right now. But what we're thinking for Boost developers is to kind of ease complexity costs and just the overall time that community developers should have to spend on these boosts. All you should really have to worry about is building these forms, the contracts, and the transactions. And then all you have to do is leave it in your dev test list, and then we would be able to wire together the boost for you. Just to reduce a little bit of overhead. Obviously, if you want to look at the code or the docs and build out, the packaging and stuff yourself, obviously, very, very safe to do so. I know Scott did that on his most recent boost, so. Go. I'd be pretty stoked if it executes properly on the first go.
Well, it's good to get the mistakes and the tutorial.
Oh yeah, true. Yeah, fair enough. There's that is right actually.
Well, let's check out view details.
Sure. Yeah. So value is here, name is here, symbol is here, and I believe that is our safe address right here. So this should work. Yeah. Also, we don't have our notice we don't really have our custom proposal. If we wanted to, we can build a custom face here for this proposal card so that it would say, like proposal name here and then token name and token symbol and all that right here so that we wouldn't have to necessarily go into the details.
Over to the vault, see if the other one showed up.
See if the other one the token?
Yeah.
Oh yeah, okay, cool.
And I guess after you run this, it should be in there.
Oh yeah, look at that, eh?
BTTs.
Yeah, that's it. Million BTTs.
The value for $1.
Wow, they're worth $1.
People are loving it.
Let's do that a million times.
That's one of those.
We got a better peg than most stablecoins right now.
It's one of the name collisions we were talking about earlier with getting price data. CoinGecko or something.
Where did BTT come from?
There must be a BTT token someone did and registered with CoinGecko at some point.
It's the BitTorrent token. Yeah, yep. It's a legitimate token.
Oh, shoot. They definitely do not have that unit cost bias.
So we are the imposters this time.
How come we don't query by address?
I don't know. I have to ask Sam. Maybe we can't.
Yeah, it's not provided in the API. You have to query it by symbol or name.
That's so dumb. Could you at least get like a query of multiple results that include the address so you could filter or something? That's probably out of scope right now, but
yeah, I'm not sure. I kind of it's one of the parts of the app that I'm a little bit fuzzy about because a lot of it is on the back end, but. So we're almost there, folks. A boost in an hour and 40 minutes. I'm now, because I said that, it's going to fail. No, maybe not.
Yeah. It's take a little time sometimes
for it to sync.
Treasury, or the vault page, like every 5 or 10 minutes it updates, but.
Mm-hmm.
Maybe you'll see it in there. We can at least check the
right.
Awesome. Now we could push this up to production and people could mint 1 million tokens.
Maybe
I think one of the use cases I think would be really fun with this is...
There we go. There's our million token.
Awesome.
Yeah.
Every member could mint their own personal token. When you join, then you go mint 1 million of your own token. And
that is actually kind of interesting. Yeah, like kind of a personal tokens within a DAO kind of thing.
Mm-hmm.
It's weird, but cool.
You just like bribe people with them or whatever you want.
Jord coin.
Yeah.
All in favors and stuff.
Right. My credibility's on the line. I'm staking half my Jord token on something, or that'd be kind of neat. Yeah, so there it is. As Deacon was saying, it probably will take a little bit for the Vault API to load that in. Let's take a look here. Yeah, I might have to do they have a little refresh button here for that too, but.
So was BTT one that you made earlier testing the contract?
Yeah, and as Deacon said, it's used. There we go. Yeah, 1 million.
It's not worth $1.
No, not worth those sweet Rinkeby dollars. Cool. So I think that's probably a great place to leave off. And And I think we could get in maybe if we do something like maybe 2 weeks from now or a week from now, and kind of get into a little bit more of the nitty gritty, a little bit more of the custom code and some of the nonsense that happens when we use the boost rails, and debugging. And like I said, I don't think I've ever had one work on the first go before. You have to do a little bit of debugging. There are some tools to help you with that. And a lot of it is just looking at your custom React fields, and that's pretty much it.
Yeah, cool. I recorded this, so over the next week we're gonna chop up the video and make some content out of it too.
That's super exciting to hear. Thank you.
Oh, no problem. Yeah, anyone is free to ping me. Let me know if you have any questions at all. If you're building at a boost or just playing around, whatever you want, just let us know or let me know, and I'll try to get back to you in a reasonable amount of time. It gets a little frustrating, I'll say, if something doesn't work as planned, because it is so abstracted that like if there is something that's going wrong, it's hard to go in and fix things. So yeah, just let me know.
Thanks a lot, man. This was awesome.
Yeah, thanks.
No worries. Thanks for coming by, everyone. All right, see ya.
Crushed it.